Hello everybody. In this video, we're going to be talking about Huffman's algorithm. So let's get into it. So here we've got a table, right? And in this table, there's two columns, and the first column is character, the second column is frequency. So the characters I have here are A, B, C, and D, right? And this table is just saying that, I guess in like a phrase or anything like that, I have a frequency of 2 for the character A, and a frequency of 4 for the character B, frequency of 6 for the character C, and a frequency of 8 for the character D. And the idea of Huffman's algorithm is actually to make prefix codes for these characters according to their frequency, right? So if a character was to have more characters, this basically means it should have shorter prefix codes, right? So let's get into it. The first thing I would actually want to do is actually order these characters from least to greatest. All right, so I want to have A2, and then B4, and then C6, and then D8. All right, okay. So what I actually like to do here is I would actually want to make some rectangles here. So let's draw some rectangles. We're going to have our first rectangle for A2, another rectangle for B4, another rectangle for C6, and another rectangle for D8. Alrighty, let's put them in here. What are our values? So A2, B4, C6, and D8. Okay, so the first thing I would actually want to do, let's say if this was the first step, the actually second thing I would actually want to do here is to combine the lowest two characters, right? So in this case I have A and B, which are the lowest, the two smallest characters here in this case. So let's combine them into one node, and we're going to call them AB6, right? So let's do that. I'm going to have one rectangle for both of them, and I'm going to call it AB6 and replace it, right, where it actually belongs again in another minimum order queue, I guess. So let's do this. I'm going to have AB6, and then I'm going to have C6. Let's go with the C6. And we're going to have D8. Okay, let's do that. Okay, so the reason why I didn't really move AB upwards and past C is that it doesn't really matter in this case. They're both the same, 6 and 6, so I'm not going to really worry about it too much. But as I'm building my tree, I actually want to show my work. So I'm actually going to take a little screenshot of this. And then I'm actually going to paste it in here. See if this actually works. Paste it here. Does it not going to work? I think it's not going to work for me. Okay, it worked. So let's put that right underneath over here as the two things that are going to be making up this AB. Okay, let's make two lines. So it's going to be from here and here. All right, now we're going to be doing the same thing over again. So step 3. So step 3, I'm actually going to combine AB6 and C6 together to get ABC12, right? So I'm actually going to take this same tree over here, which is going to make life a lot easier. And this is going to build up. But one thing to note is that actually I should get rid of this D8. You don't want that D8 there. Just want this part, right? Let's just grab that. Boom. One thing to note is that your D8 is actually going to be less than this. So I'm going to be moving it to the left. So I'll show you what that means. Let's put the A, B, because this is going to give us a value of 12, correct? We'll put these two together. Boom. We're going to get A, B, C, 12. All right. But we're not done yet because we forgot our D8. So let's add a rectangle for that. Boom. It's going to come a little before it. Oh, that's not a good rectangle. Let's make it a little, okay, that's fine for now. So let's get rid of that. And it's going to be D8. All right. So now you have to combine D8 and ABC12 together. So let's do that. We're going to get ABCD 20. So that's for step 4. In this case, we're going to use the same tree one more time. But it's a little Can I do this? Okay, I'm actually gonna have to, never mind, this should be fine. This should be completely fine. We're gonna paste it down here, and we're just gonna take it like this, and we're just gonna put these two together. So let's put D8 and ABC12 together. Make a little rectangle. And so at the top, we're going to have A, B, C, D, 12 plus 8, we're going to get 20. Okay, now we're basically finished, and the final part is basically just to get our prefix codes. So for every left term, we're going to put a 0. For every right term, we're going to put a 1, like so. So we're going to have 0, 1, left term 0, 1, left term 0, right term 1. And so I'm going to write down my prefix codes, which is the final part of this, which are going to be, let's look at D. D is going to have a prefix code of 0, right? And I'm going to look at the single characters, right? Not for ABC or anything like that. You could look for ABC and stuff, but I'm just going to work with my single characters for now. So we're going to have D, which is going to be 0, and if we go down the tree here to ABC, if I want to get for C, we'll go to 1, and we'll go to 1 again. So C is going to be 1, 1. Okay? Now A is going to be 1, 0, 0. So A is going to be 1, 0, 0. And then B is actually going to be 1, 0, 1. And we're actually going to see if this makes sense, right? So D appears how many times? 8 times, right? So what frequency does C have? C has a frequency of 6, right? Let's put that there. And A has a frequency of 2, right? And B has a frequency of 4. Okay, so we'll see that the smaller our frequencies are, for example, we have 2 and 4, we can see that our prefix code is going to be larger, right? So we're just going to make this as optimal as possible. And for 8, let's say we're going to have 0, right? And for 6, we're going to have 2, all right? So hopefully this made sense. Yeah, and that is it for Huffman's algorithm. Have a good day.